Okay, so here are my solutions. For function g of x, there's a reflection in the x-axis, vertical stretch by 2, and a vertical translation up 1 unit. For function h of x, there's a vertical stretch by 3, and a vertical translation up 2 units. For r, there's a reflection in the y-axis, a horizontal compression by a half, horizontal translation 1 unit to the left, and for function q, horizontal compression by a half, and a horizontal translation 3 units to the right. Alright, let's move along, please. And we will move along we'll change from exponential functions to logarithmic functions. So now we'll take a look at the logarithmic functions and again go through exactly the same process. However, realize that the function of y equals log of x to some base of b, these are all inverses of the function that's of the same form, x equals b to the y. Remember that y here is the exponent, and logarithms are nothing more than exponents. So if this logarithm equals y, and we know that y is the exponent, then that means that log of x to the base b is is an exponent. And we find these logarithms by taking the original exponential function and reflecting it in the line y equals x. Okay, so the same transformations apply again. Vertical stretch and compression, when you multiply the log by some constant, you're multiplying all the y values by that constant. So the original function y equals log x, when it's 2 times log x, all y values that you see along here are multiplied by 2. So one of the more pronounced ones would be when x equals 10, y equals 1 for the original. Then in this case, for the transformation multiplying by 2, when x equals 10, y equals 2. Same thing goes for this other function, y equals 5 times log x, when x equals 10, the original y equals 1, but on this transform function, when x equals 10, y equals 5. And with negative 3 times log x, again, when x equals 10, y equals 1 for the original. For the transformed function, when x equals 10, y equals negative 3. Vertical translations, exactly the same. All these values are just translated up or down according to the sign and the value of the vertical translation. So we're adding 2, all the y values get added 2, and when we subtract 3, all the y values, 3 is subtracted from all the y values to get this transform function here. We will continue moving along at a blistering pace. Horizontal translations, they're indicated by a addition or subtraction of some constant inside the bracket with the x. Same kind of thing goes here. So here's the original function, log x. When it's log of x plus 3, all the x values, 3 is subtracted from all the x values. If it's plus 3, it's subtracted, so it's moving to the left 3. So this vertical asymptote of x equals 0 gets shifted over to x equals negative 3. When we subtract 2, that means that the whole function gets translated to the right 2. So again, the vertical asymptote at x equals 0 becomes a vertical asymptote at x equals positive 2. For this function, negative x plus 1, the negative reflects the function in the y-axis first. And this can actually be written as log of negative x minus 1. We have to factor that negative out. And so then when we've got x minus 1, that means that after we reflect the function in the y-axis, then we translate it to the right 1 unit. Therefore, the vertical asymptote at x equals 0 gets shifted over to x equals positive 1. Okay, so don't be fooled by that. Make sure that you factor out that negative from both of those terms inside the bracket. And then for the vertical stretch or compression, horizontal, I'm having a hard time today, we've got a value multiplied by the x inside the bracket. And again, the original function here, y equals log x. If we're multiplying inside the bracket by 2, that means that we're dividing all of the x coordinates by 2. So in x equals 1 for the original, x equals a half for the transform function. When x equals 10, which is way down here on the original function, x equals 5 on the transform function. Notice that the y value is 1, which is exactly the same as the y value would be for the original when x equals 10, way down here. And again, negative 0.5 times x, the negative means that we're reflecting in the y-axis first, and then we're dividing by a half, which means that we're flipping and multiplying by 2. So instead of having an x-intercept of negative 1, it then gets stretched to be negative 2. Now let's test to see how well you have absorbed all that wonderful information. So again, here are all the logarithmic functions that I'm giving, including their equations. Please write the transformations in order from left to right as you see them in the equations. Okay, please do that and come back and check your answers in a few minutes when you have finished that. Okay, so just to check, for function g of x, horizontal compression by a half and horizontal translation 2 units to the right. Function h of x, vertical stretch by 3, horizontal compression by a half, and a vertical translation up 2 units. And then for equation q, reflection in the x-axis, vertical stretch by 2, horizontal translation left 2 units, and vertical translation 3 units down. Now let's do a little bit of review of laws, just so that we have an idea of the similarity between exponential laws and logarithm laws. Okay, so let's, why don't you pause the video now and see if you can fill in the laws of product. So let's say, so we have, what are we going to say, a to the m times a to the n. What would that give you using exponent laws? And log of a plus log of b, what would that give you? Okay, so see if you can remember what all those logarithm and exponential laws were that we looked at in first semester. Okay, pause the video now and come back and check your results, please.